Hey guys, tonight we dig deep, far below the soil, beyond the stone, into the molten arteries that keep our planet alive. Down there, the Earth isn't silent. It hums, it breathes, it beats. Beneath your feet, molten rock flows like blood through invisible channels, shaping mountains, oceans, and everything in between. Les Italie, 2008. Imagine yourself shrinking small enough to drift through the cracks in the crust. You descend past the granite bones of the continents, past the basalt plains of the ocean floor. The air grows heavy with the scent of hot minerals and ancient steam. You feel vibrations through your feet, deep, slow, rhythmic. It's not a noise you can hear. It's something you feel. The earth, to you, might seem still. But that calm is an illusion. Just beneath, there are rivers of rock so hot they glow 1,200 degrees Celsius on average, flowing in massive, swirling cells. These flows are the invisible engines that drive everything we know about continents, volcanoes, and earthquakes. The ground isn't dead matter. It's part of a living machine that never truly rests. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'd love to know where you're listening from tonight, your city, your country, maybe even what time it is there. The world is vast, yet here we are, sharing this quiet moment across time zones and tectonic plates. Now, dim the lights, and let's ease into tonight's journey together. You drift lower still, through the crust, a fragile eggshell floating atop a churning mantle. The rocks around you glow a deep red-orange, like embers in a dying fire. You can almost sense the heat as it rolls upward, transferring energy that has been trapped since the planet's birth. That heat is ancient. Most of it comes from the radioactive decay of elements like uranium, thorium, and potassium, tiny atoms splitting apart, releasing warmth into the deep Les Italie, 2008. These invisible reactions are what make the mantle flow, what push continents apart, and what ultimately give rise to the landscapes we call home. It's strange, isn't it? The same nuclear forces that humans fear above ground are the very ones that have sustained the Earth's inner life for billions of years. Maybe that's one of the universe's quiet jokes, creation and destruction sharing the same spark. Down here, pressure replaces air. Every cubic inch of rock bears the weight of everything above it. It squeezes, reshapes, and melts under forces we can barely imagine. You can feel the pull gravity pressing you inward, the same way it has compressed the planet into layers. Crust, mantle, core, you're surrounded by slow motion, yet everything is in motion. Tiny crystals of olivine shimmer in the molten dark. They rise and sink, carried by convection like leaves in a lazy stream. These minerals will one day be part of mountains, ocean floors, maybe even the sand beneath your toes. Each grain holds a story billions of years old. As you float, you sense the deep connection between the surface. You know the forests, the cities, the seas, and this secret interior. Every tremor, every eruption, every new island is a heartbeat of this massive living sphere. Without it, the planet would go cold, its oceans still, its air thin and lifeless. You think about the Earth not as an object, but as an organism with a crust like skin, a mantle like muscle, and a core like a heart. Maybe alive isn't the right word, but it's close enough. After all, it grows, it moves, it changes, and it sustains us in ways we still don't fully grasp. The light fades as you drift deeper into the mantle's great currents. Somewhere below, iron and nickel churn in the outer core, spinning a magnetic field that protects you from solar wind. Somewhere above, the continents glide like rafts across the molten sea. And somewhere in between, you float a tiny witness to the pulse that has never stopped since the planet's birth. Maybe that's what connects all things. Motion that never ceases. The same rhythm that beats within your chest echoes, faintly, in the depths of the world. You and the planet, both made of atoms, forged in stars, both warm, both restless, both alive in your own ways. The Earth is not just where you stand. It's a great, ancient being whose heart never sleeps, a companion to the stars, a guardian of life, a furnace of renewal. And as you listen, in the quiet of your room, perhaps you can almost feel it. A deep, slow thrum, older than any ocean, steadier than any clock, the heartbeat of Earth. A planet born in fire, That's how it all began. 4.5 billion years ago, the solar system was nothing more than dust and chaos. You hover now in that young, turbulent void, tiny fragments of rock and metal swirling around a newborn Sunday. They collide, fuse, and shatter again, each impact a flash of light in the darkness. From these collisions, the Earth begins to take shape, not quietly, but violently. Canup Asphaug, 2001. You drift closer to the molten sphere that will one day be home. Its surface glows with heat, a vast ocean of magma stretching in every direction. Volcanoes erupt endlessly, their plumes arching high into the young atmosphere. Lightning dances across clouds of vaporized rock. You can almost feel the waves of radiation from the sun beating against this unprotected world. At first, the Earth is too hot for oceans, too unstable for continents, too wild for anything resembling life. The air is thick with carbon dioxide, sulfur, and steam, noxious and heavy, but rich with the ingredients of transformation. Beneath that stormy veil, the surface roils like a boiling pot. Then, slowly, cooling begins. The molten outer layers start to harden into thin crusts that crack and sink, then harden again. It's an endless process of breaking and reforming the planet's first attempts at stability. Imagine the sound. The deep, slow groan of stone meeting stone. The hiss of magma forcing its way through the fractures. As the cooling continues, rain begins to fall for thousands of years without stopping. Steam condenses, and great floods carve the first basins that will one day hold the oceans. The surface starts to shimmer, reflecting the dim sunlight. It's the first calm after an era of cosmic violence. Yet, beneath that crust, the heart of the Earth still burns. Radioactive decay deep inside the mantle continues to release energy. The core, a molten sphere of iron and nickel, spins restlessly, generating heat and motion that will never cease. That energy becomes the foundation for everything to come. Volcanoes, mountains, oceans, life. The Earth's heartbeat begins here, in the echoes of fire and impact. You drift over the newborn surface and watch continents begin to form, drawn together by gravity and convection. They move slowly, like ice flows on a glowing sea. It's hard to imagine that each of these massive plates, crustal fragments thicker than the highest mountains, will one day collide, merge, and tear apart again. Somewhere nearby, a collision changes everything. A Mars-sized object named Theia strikes the young Earth, tilting its axis and scattering molten debris into space. Canup Asphaug, 2001. From that chaos, a ring of glowing material forms around the planet and, over time, that ring becomes the moon. The Earth wobbles now, its orbit forever altered, but its rhythm persists. The moon begins to tug at the planet's oceans, and the tides are born. A partnership begins, a slow cosmic dance that stabilizes the Earth's spin and softens the extremes of day and night. Even then, in that primal epoch, balance was already forming out of destruction. As millions of years pass, the crust thickens, though cracks remain like veins across cooling skin. Lava still seeps upward, venting the planet's fury, but the surface grows calmer. The rains persist, carving valleys and depositing minerals. Oceans deepen, and the first whispers of chemistry, amino acids and simple carbon chains drift in those warm seas, nurtured by heat and time. You watch it unfold, realizing that life would not exist without fire. The energy that once threatened to consume the planet now drives its renewal. Even destruction has purpose. Every eruption, every impact, every burst of radiation contributed to the shaping of a world capable of sheltering life. In that way, Earth's origin mirrors your own story. Chaos first, then order. Heat first, then calm. The elements that formed your body, iron, calcium, carbon, were born in those same fires. The planet and you share ancestry in stardust and gravity's relentless pull. Maybe that's what makes this journey so intimate. You aren't just walking upon the Earth, you are Earth, remembering itself through human eyes. The warmth in your chest is the same warmth that once melted mountains. The pulse in your veins beats to the same tempo as the mantle currents below. As the magma oceans finally crust over, the first continents emerge, like islands in a sea of red. You can almost hear the sigh of a planet taking its first steady breath. The surface cools, the storms ease, And for the first time, there is quieter silence vast enough to cradle possibility. In that silence, the Earth's molten heart keeps beating, unseen yet unstoppable. From here on, every tremor, every ripple, every mountain born will be a whisper of that original fire, a reminder that even the calmest worlds begin in chaos. The planet has survived its birth, and the rhythm that began in fire still flows beneath your feet today. You feel it faintly, even now, the echo of creation, pulsing through time, layers like a symphony. That's what you discover as you drift through the body of the planet. Each stratum of Earth plays its own note in a slow, resonant harmony, together composing the song of our living world. Dziewonski and Anderson, 1981. You begin your descent at the crust, the fragile outermost shell, thinner than an apple's skin compared to the planet beneath. Under continents, it stretches roughly 30 to 70 kilometers deep. Under oceans, barely 10. Yet this brittle layer carries every forest, every city, every ocean wave you've ever known. It is the home of stories, and the mask of something far greater. The crust feels cool at first, familiar granite, basalt, and sediment pressed into ancient memory. But below, the tone deepens, the temperature rises, the colors shift from muted grey to amber, to red, then to a near-invisible glow. You slip into the mantle, a realm of stone so hot it moves like putty, flowing slowly over millions of years. Here, the Earth's rhythm begins to take shape. Mantle rocks, mostly peridotite, rich in olivine, circulate in vast convective loops, transferring heat from the core outward. As you float, you see shimmering plumes of molten material rising like candle flames, while cooler slabs of ancient crust sink downward. It's a dance of opposites, a loop without beginning or end. The mantle hums, deep and constant, like the bass line of the planet's symphony. You travel deeper still, toward the boundary 2,900 kilometers down, where the solid mantle meets the liquid outer core. It's a place of violence and transition. Seismic waves tremble differently here, revealing a dramatic shift in composition and density. Iron and nickel dominate this boundary, glowing in fluid form. The sound of movement changes from muffled vibrations to a deep metallic thrum. In the outer core, the rhythm grows louder. You watch eddies of molten metal swirl under immense pressure, twisting and folding like streams of sunlight caught in motion. This liquid iron moves faster than anything above it, and in that motion, electricity flows. Through the geodynamo process, these currents generate the magnetic field that shields all life from the sun's deadly winds. Olson Christensen, 2006. The outer core feels alive. You sense heat radiating outward, a warmth that reminds you of the earliest fires. Each motion here is both chaotic and purposeful, like fingers striking an invisible drum, and at the center of it all lies the inner core, a sphere of solid iron about the size of the moon. It is unimaginably dense, under pressures more than 3 million times that of the surface. Yet despite the crushing force, it remains stable, crystalline, resonant. You drift toward it, and for a moment, the vibrations seem to align with your own heartbeat. The frequencies merge, two pulses meeting across time and matter. Seismologists have even detected subtle variations in the inner core's spin, as if it sometimes rotates at a slightly different pace from the rest of the planet. Song and Richards, 1996. The Earth's heart doesn't just beat. It wobbles gently, its tempo influenced by the forces above. You listen, and realize each layer has its own rhythm. The crust crackles like percussion, earthquakes and fractures, short and sharp. The mantle murmurs in low, slow tones, convection currents that shape continents. The outer core thrums a liquid orchestra of metal and magnetism, and the inner core hums softly, a pure note of stability at the planet's center. Together, they create a song too deep for ears to hear, too vast for hearts to contain. And yet, you feel it, the resonance between your breath and the breathing of the world. Maybe that's what balance truly is. Different layers, each with its own voice, finding harmony through tension. The crust may crack, but the core keeps spinning. The surface may cool, but the mantle still dances. It's not perfection that keeps Earth alive, it's motion. Imperfection moving in rhythm. You remember that the Earth was once fully molten, a chaotic melody of collisions and heat. Over billions of years, density and gravity composed order from noise, separating light silicates above and heavy metals below. The process, called planetary differentiation, turned chaos into structure. Dziewonski and Anderson, 1981. Even disorder found its music. As you hover near the heart of the world, you feel an odd calm. The pressure here could crush mountains, yet it feels strangely peaceful, as if the planet has found equilibrium within its storm. You rise slowly now, retracing your path. The deeper tones of the core fade into the gentle warmth of the mantle, then into the brittle cool of the crust. The symphony becomes quieter, but it never ends. It continues beneath you, unbroken, as you walk across the surface each day, unaware that beneath your steps, the greatest orchestra in the solar system is performing endlessly. Maybe that's the quiet truth of our existence. We live upon music too slow to hear. The mountains rise to it, the oceans sway with it, and even your pulse seems to follow its tempo. And so, the layers continue a planet in harmony with itself, conducting a melody of fire, stone, and iron that will play until long after our kind has gone. The heartbeat of Earth not just felt, but composed. The mantle's slow dance, a motion so vast and patient that you could live 100 lifetimes and never see it shift by more than a few centimeters. Yet this dance is the very reason mountains rise, oceans open, and continents drift apart. Davies and Davies, 2010. You begin your descent once more, through the crust, brittle and cold into the mantle's glowing twilight. The airless heat envelops you, and the ground seems to ripple as though it were breathing. Beneath the continents, the mantle stretches nearly 2,900 kilometers deep, made mostly of silicate rocks, so hot and pressurized they move like thick honey. Here, time loses meaning. A single convective loop where hot rock rises, cools, and sinks again can take hundreds of millions of years to complete. But in that endless slowness, the planet's shape is constantly rewritten. The mantle moves not in bursts or jolts, but in great sweeping currents, the silent ballet that drives tectonic plates above. You hover above one of those immense upwellings, a plume of superheated rock rising from deep within the mantle. It ascends like a ghostly column, its edges shimmering. The rock isn't liquid in the way you imagine. It's solid, yet so plastic under immense pressure that it flows. Each movement releases a faint sound, a low, resonant murmur that vibrates through the bones of the world. The motion begins with heat. Deep within the planet, radioactive elements, uranium, thorium, and potassium, decay and release energy. This heat rises toward the surface, setting the mantle in motion. Davies and Davies, 2010. The hotter, less dense material ascends, while cooler, denser rock sinks. Convection begins. It's the same process that stirs water in a boiling pot, or moves air in a storm cloud. Only here, the fluid is stone, and the scale is planetary. You drift with the current, feeling its pace. At the top of the loop, near the crust, the molten rock spreads sideways, dragging the tectonic plates apart. Beneath the oceans, this happens at mid-ocean ridges, where new crust is born. Far away, on the other side of the loop, cooled plates sink again into the mantle, carrying old crust downward to be melted and renewed. This is the planet's circulatory system recycling itself from the inside out. In the glowing dark, you can almost trace the outlines of the continents above. Africa drifts northward, South America moves west. The Pacific plate slides under Asia, all of them gliding on the mantle's invisible tide, like rafts on a breathing sea. As you rise higher, you see the edges of continents marked by fiery scars, volcanoes, subduction zones, earthquakes. These are the mantle's exhalations, the surface expressions of deep, slow motion. The heat that began as silent atomic decay emerges here as light and ash and life. Somewhere below your feet, 2,000 kilometers deep, you glimpse something rare. The large, low-shear velocity provinces, vast regions near the core, where seismic waves slow dramatically, hinting at strange, dense materials. Scientists think they may be remnants of ancient slabs of crust that sank billions of years ago, still slowly blending with the mantle. Garnereau and McNamara, 2008. Even here, the past doesn't vanish. It melts into the present, part of the ongoing rhythm. You realize how everything connects. A volcano in Iceland, a trench in Japan, a desert in Africa, all linked by currents you cannot see. The Earth is not a static ball of rock, but a self-renewing organism, digesting its own surface, rebuilding itself endlessly. In this slow motion, you find an odd sense of peace. The mantle doesn't rush, it doesn't panic, it simply moves, unhurried and unstoppable. Maybe that's the secret of endurance: to change without haste, to evolve without noise. You reach a zone where the mantle's currents brush against the crust. The rocks here are stretched thin, glowing faintly. Magma wells upward through fractures, sometimes erupting to form new land. In those moments, the deep mantle briefly touches the sky, a pulse breaking the surface. You think of how fragile the crust is compared to what lies below. All the noise of human life, wars, songs, dreams plays out atop a shell thinner than paper. And yet, beneath it, a quiet force moves continents, raises mountains, and reshapes oceans. The mantle's dance is both invisible and absolute. As you listen to the slow hum of molten stone, you wonder if the planet feels joy in its motion. Maybe this constant circulation, destruction, and renewal is its way of breathing, of staying alive. You drift upward again, carried by the same convection that drives the world. The flow slows, the heat fades, and the crust's cool calm returns. But now, when you look at a map at the jagged coastlines and mountain ranges, you'll know. They're not random. They are the footprints of a dancer moving through geologic time, a record of the Earth's steady, beautiful choreography. And beneath it all, the rhythm continues deep, slow, and eternal. The breath of plate tectonics, slow, patient, and unstoppable. It is the rhythm by which continents drift and collide, by which oceans open and close, by which mountains rise only to crumble again. This is how the Earth exhales, not in seconds, but in millions of years. Mackenzie and Parker, 1967. You stand now high above the planet, looking down. The Earth's crust no longer seems solid. You see it instead as a mosaic of immense slabs, tectonic plates floating on the mantle's warm, pliant surface. They jostle, grind, diverge, and sink, their borders glowing faintly like seams in living skin. Each plate moves only a few centimeters per year, about as fast as your fingernails grow. Yet over eons, these motions have rearranged entire oceans and continents. What now separates Africa and South America was once a single landmass. What is now the Himalayas was once the seafloor of the Tethys Ocean. The planet is never still. It only seems that way because we move too quickly to notice. The engine beneath this motion is the mantle convection you met before: heat rising, rock spreading, and gravity pulling cooled crust downward. You hover now above a mid-ocean ridge, the vast underwater mountain chains where new crust is born. Magma wells up from the mantle, hardens as it touches seawater, and pushes the ocean floor apart. It's like watching the Earth inhale, expanding its surface in a slow, graceful breath. Far away, on the other side of the world, another plate edge begins to descend. Old, heavy crust bends downward into a trench, sliding into the mantle to melt and mix again. This is the exhale, the return of ancient rock into the fiery depths. The Earth breathes in through ridges and out through subduction zones. Every cycle of creation is balanced by one of return. You follow one of those descending slabs downward. It groans as it bends, releasing earthquakes that ripple through the ocean floor. Water trapped in the subducting crust escapes, lowering the melting point of nearby mantle rock and triggering the rise of magma. Volcanoes awaken above these zones, their eruptions releasing carbon dioxide, sulfur, and minerals into the atmosphere, ingredients vital for life. Hoffman, 1997. Even destruction gives rise to renewal. You rise now to view the full system. The plates form a planetary machine, a mechanism of energy distribution and recycling. At divergent boundaries, new rock emerges. At convergent boundaries, old rock returns. At transformed faults, like California's San Andreas plates, slide past each other, converting strain into sudden motion. Each interaction is part of the same continuous breath, the same heartbeat. You drift toward the Pacific Plate, the largest of them all. It moves northwestward, diving beneath Asia and the Americas, giving rise to a fiery ring, the Ring of Fire, where earthquakes and volcanoes cluster. You can almost see the pulses of energy traveling along the boundaries, like muscle contractions in a giant living being. In this moment, the Earth feels strangely human. Its movements mirror your own respiration. Inhale, exhale, expansion, contraction. Maybe that's why the planet feels alive to us, because we too are creatures of rhythm. Our hearts beat, our lungs rise and fall, our cells cycle endlessly between creation and decay. The same pattern, written in different scales. As you drift closer to the crust again, you notice the subtle signs of motion. Mountain ranges buckling upward, rift valleys tearing apart. Iceland sits atop a ridge, split between two plates, one part drifting toward Europe, the other toward North America. Every few years, new land emerges from the sea. The planet keeps rewriting its own map. Scientists like Mackenzie and Parker, 1967, once pieced together this story using magnetic stripes frozen in oceanic crust. As magma at mid-ocean ridges cools, iron minerals within it align with Earth's magnetic field. Each time the field flips, those stripes record the reversal, forming a symmetrical pattern on either side of the ridge, a fossilized logbook of spreading seafloors. From these quiet minerals, the idea of plate tectonics was born. It's humbling how the largest motions in existence can leave traces so small, so silent. You look again at the moving plates and realize how their slow collisions shape everything above. The Andes rise where the Nazca Plate dives beneath South America. The Himalayas tower where India thrusts into Eurasia. Even the air you breathe, filled with oxygen released from weathering rocks and living soil, owes its balance to the tectonic cycling of elements. The Earth breathes deeply, and with every breath, it renews the conditions for life. Perhaps that's the quiet beauty of it all. Our world is not static but alive with motion, change, and renewal. And just as your lungs never tire of drawing in air, the Earth never tires of remaking itself. Its movements may be slow, but their music is endless. Above you, clouds drift over continents that will not stay as they are. Beneath you, the mantle churns, patient and tireless. The plates glide onward, in, out, together, apart, keeping time with a rhythm older than life itself. You listen to that rhythm and exhale softly. Maybe the Earth's breath and your own are not so different after all. Subduction, where the old sinks down. Here, the Earth consumes its own crust, not with violence, but with purpose. It's a quiet act of renewal, where the planet takes what's been used and folds it gently back into its molten heart. Stern, 2002. You hover now above the edge of a continent, where deep ocean meets rising land. Beneath the surface, something vast and invisible is happening. An oceanic plate, heavy and cold, begins its slow descent beneath a lighter continental one. The seafloor bends like a bow, forming a deep trench, a scar at the boundary between life above and transformation below. You drift down toward it, the Mariana Trench, perhaps, or the Peru-Chile Trench, where darkness thickens and pressure builds. The air is gone. The water presses against everything with a weight beyond imagining. Even light cannot reach here. But you feel motion, faint yet steady, as one plate slides beneath another, sinking into the mantle like a page being turned in an endless book. At the boundary, friction crackles. Rocks grind and rupture, generating earthquakes that ripple outward like shivers through the crust. These are the planet's whispers of adjustment, sudden releases of the tension that builds as two giants wrestle. In those moments, the Earth remembers its strength. You follow the subducting slab deeper into the mantle's glowing dimness. Around you, the basaltic crust begins to change under pressure and heat. Minerals like amphibole and pyroxene break apart and reform into denser structures. Eclogite, garnet, perovskite, the slab grows heavier, accelerating its descent. It's a transformation both chemical and physical, a descent into metamorphosis. Then, something remarkable happens. The oceanic crust, though sinking, carries water locked within its minerals. As it descends, that water is squeezed out, released into the overlying mantle, and like a breath of oxygen to a fire, that water lowers the melting point of the surrounding rock. Pockets of magma form, rising through cracks and fractures. Above, volcanoes awaken. Their eruptions, fierce yet purposeful, build mountain ranges like the Andes and the Cascades. From the ocean's edge to the high sky, this hidden process sculpts continents and shapes atmospheres. What sinks in darkness re-emerges as light. The gases released carbon dioxide, water vapor, sulfur climb into the sky, feeding clouds and rain. They help balance the climate, sustaining the thin film of habitability we call home. Subduction, destruction though it may seem, is part of life's breathing, the Earth's grand carbon cycle. The rocks that vanish below will one day return as new crust, new soil, even new air. You drift beside the sinking plate and notice streaks of color glowing faintly blues from serpentine minerals, reds from molten inclusions, silver from thin veins of quartz under pressure. It's strangely beautiful, like stained glass lit from within. You sense that even in descent, there's grace. It's easy to think of this as loss, as disappearance. But nothing here is wasted. The crust that vanishes becomes the fuel for the next eruption, the foundation for the next continent. Even destruction is just another form of movement. Above you, island arcs form Japan, the Philippines, Indonesia. They're strings of volcanic peaks, each one marking where the mantle's heat escapes through the crust. Some of these islands rise and fall in geologic time, living entire lifespans of creation before slipping beneath the waves again. As you watch, magma chambers pulse, their pressure building. When the time comes, they release, sending ash into the stratosphere, light scattering in orange and violet hues across the sky. The eruption is violent, yes, but it's also creative. New minerals crystallize in the cooling lava. New land emerges from the sea. The cycle continues, unbroken. You realize that subduction is not just a downward motion, it's a circle. Rock becomes magma. Magma becomes land. Land becomes sediment. Sediment becomes rock again. It's the deep time equivalent of breathing, the planet's way of keeping its body in balance. Scientists have traced these cycles through isotopic signatures, fingerprints in the elements themselves. Traces of subducted ocean crust have been found in volcanic rocks thousands of kilometers away. Proof that the material never truly disappears. Stern, 2002. It simply changes state, joins another part of the Earth's anatomy, and continues the rhythm. As you rise back toward the surface, you can feel the heartbeat of this process, slow, steady, eternal. You think of your own life, how endings often feel final but rarely are, just as the crust sinks only to rise again. Perhaps the things we lose are never truly gone, just waiting to return in another form. At last, you break the surface. The horizon glows faintly with volcanic fire. You take a breath and feel, deep beneath your feet, the pulse of subduction, the old sinking down, the new preparing to rise. Maybe that's how the planet stays alive. By learning how to let go. Mid-ocean ridges, birthplaces of new crust, the shimmering scars where the planet creates itself anew. Here, beneath miles of seawater, the Earth opens its veins and exhales molten breath into the darkness. Parsons and Sclater, 1977. You drift now along the ocean floor, surrounded by blackness so complete it feels like the absence of time itself. Yet ahead, a faint glow emerges, not sunlight, but something deeper, born from within. The ridge rises before you, stretching across the seafloor like a stitched wound, thousands of kilometers long. This is where the planet is reborn every second. The heat grows as you descend closer. The water vibrates faintly, filled with whispers of hydrogen sulfide and the shimmer of minerals. At the ridge's crest, the crust splits open. Magma from the mantle surges upward, filling the gap between tectonic plates. When it touches the icy seawater, it cools and hardens instantly, creating new basalt, the youngest rock on Earth. You watch as this newborn crust pushes outward, slowly widening the ocean basin. Each year, only a few centimeters are added, the speed of a growing fingernail, but multiply that by millions of years, and entire oceans appear. It's the grandest form of patience, sculpting continents with the gentleness of time. All around you, life thrives in impossible conditions. Towering chimneys of black and white smoke rise from hydrothermal vents, mineral-rich plumes that gush from fissures in the seafloor. The water here is near boiling, yet teeming with strange creatures. Ghostly crabs, pale shrimp, and tube worms taller than a person, their bodies glowing faintly from symbiotic bacteria. Those bacteria live without sunlight, drawing energy not from photosynthesis but from chemistry, oxidizing hydrogen sulfide in the vent fluids to create food. It's called chemosynthesis, and it was first discovered right here in the late 1970 seconds along these ridges. Corliss et al. 1979. In these alien depths, we found proof that life doesn't need light, only energy and patience. As you float closer, you can almost hear it, the slow, steady hiss of the earth, exhaling heat through water. Every bubble that rises carries a trace of the mantle's breath. It's a sound older than any heartbeat. You reach out toward the newly formed basalt, still shimmering with heat. Its surface is black, glassy, smooth, the raw material of oceanic crust. If you could return in a few thousand years, you'd find it dusted with sediment, colonized by coral and algae. Give it millions of years, and it might rise as part of a new continent. The ridge is not just a boundary, it's a beginning. Mid-ocean ridges are found across the planet. The Mid-Atlantic Ridge, the East Pacific Rise, the Indian Ocean Ridge. Together, they form a continuous seam around the world, more than 65,000 kilometers long. It's the largest mountain range on Earth, though most of it lies hidden under the sea. You trace its glowing path like a pulse wrapping the planet, a reminder that the Earth is still growing, still reshaping itself. Above the ridge, the ocean's surface trembles faintly from heat and rising gas. Occasionally, small volcanic islands emerge. Iceland, for instance, a place where the ridge breaches the air. There, the process that happens unseen beneath the oceans is visible as lava fountains, geysers, and basalt plains cooling under northern skies. You pause to listen. The ridge murmurs like a slow exhale, a deep sigh of creation. It's not loud, not violent. It's the sound of matter becoming form. Scientists studying the magnetic patterns of these ridges found something astonishing. As lava solidifies, the iron within it aligns with Earth's magnetic field. Over millions of years, the planet's field has flipped again and again, and those reversals are recorded as stripes in the seafloor on both sides of the ridge. Perfectly symmetrical, they are the fingerprints of Earth's growth. Parsons and Sclater, 1977. The crust remembers its birth. You think about the contrast violent magma giving rise to delicate order, chaos leaving behind symmetry. Maybe that's the Earth's secret art form, beauty carved slowly by turbulence. The temperature rises as you drift deeper into the vent field. The water shimmers, thick with minerals that sparkle like dust in candlelight. Each plume carries dissolved metals, iron, copper, zinc, that will eventually settle and harden, forming massive ore deposits. Long after the vent cools, these minerals remain as traces of the planet's secret industry. It's hard not to feel awe here. The ridge feels alive, breathing warmth into the cold abyss. Even in the quietest corner of the ocean, the Earth is at work, sculpting, creating, sustaining. You rise now through the dark water, watching the ridge fade into shadow. Above you, sunlight filters faintly through miles of ocean. You realize that this slow, patient creation beneath the waves has shaped every mountain, valley, and coastline above. Maybe creation doesn't always roar or blaze. Maybe sometimes it just whispers, flowing unseen, weaving the world in silence. The mid-ocean ridges remind you, even in the planet's deepest dark, life and light are being born not in bursts, but in slow, steady breaths. Volcanoes, the planet's fiery exhale. They are the surface expressions of a heartbeat that never stops. Bursts of creation where the Earth's deep heat finally meets the sky. Self et al. 2006. You stand now on the slope of a volcano at dawn. The air smells faintly of sulfur and wet stone. Beneath your feet, the ground is warm, pulsing with energy that has traveled upward for millions of years. Above, a column of steam curls lazily from the crater, a whisper from the planet's molten lungs. Volcanoes are more than fire. They are pressure valves for the world. Deep below, where tectonic plates meet and grind, magma accumulates molten rock born in the mantle's dark depths. It rises through weaknesses in the crust, collecting in chambers miles beneath the surface. As gases expand, pressure builds until the crust can no longer contain it. Then, with a force beyond comprehension, the planet exhales. You drift closer to the crater's edge. The air shimmers with heat. The rocks are slick with glassy obsidian, each fragment a frozen tear of magma that cooled too quickly to crystallize. You can hear a faint roar, a sound that begins low and grows, vibrating through your chest. And then, the eruption. It starts not with sound, but with silence, the deep pause before release. Then, in an instant, ash and fire burst upward, painting the sky with orange and black. The plume rises tens of kilometers high, carrying with it gases and minerals that will circle the globe. It's terrifying and magnificent. Chaos made visible. You hover above the eruption, watching the plume spread like ink in water. Volcanic ash particles, tiny shards of glass and crystal drift in the upper atmosphere, scattering sunlight. Some eruptions, like Mount Pinatubo in 1991, have cooled global temperatures by more than half a degree for years. Self et al. 2006. Each eruption, no matter how violent, reshapes not just landscapes, but climates. Beneath the surface, rivers of lava flow outward, glowing red-orange ribbons that carve new land as they cool. The heat radiates like the breath of a living creature, steady and rhythmic. The lava hisses as it meets water, sending plumes of steam into the sky. Even destruction here is creative. Each eruption builds new crust, new soil, new mountains. In Hawaii, volcanoes rise quietly, their lava flowing in gentle sheets that extend the islands year by year. In contrast, stratovolcanoes like Krakatoa or Mount St. Helens erupt explosively, their magma rich in silica and gas. The difference lies in chemistry. In the thickness of the magma, thick flows trap gases until they explode. Thin ones let them escape softly. The planet speaks in many voices, each eruption a different tone in the same deep song. You drift above a volcanic island freshly born from the sea. The ground still steams. Around it, waves crash against black rock that was liquid only hours ago. It's hot, fragile, yet already cooling into permanence. In time, seeds will drift here on the wind. Birds will nest. Soil will form. In a few thousand years, life will flourish. Creation, it seems, is patient enough to wait. Volcanoes also gift us the air we breathe. Billions of years ago, they released water vapor and carbon dioxide into the atmosphere, helping to form the oceans and balance the greenhouse gases that keep the planet warm. Even today, volcanic gases replenish the carbon cycle, maintaining the fine equilibrium between heat and life. Without volcanoes, Earth would be a cold, silent stone. You listen to the hiss and rumble beneath your feet and realize that this sound, this deep, restless breathing, is ancient. Every continent, every island, every grain of sand began as molten rock once. Volcanoes are the storytellers of the planet, retelling its origin again and again through fire. You fly over a field of cooled lava, black and wrinkled like the skin of a sleeping giant. Beneath it, the rock still glows faintly, the last embers of an eruption that ended weeks ago. Here and there, glowing cracks reveal liquid beneath, like veins beneath translucent skin. The earth is cooling, but never cold. In the distance, lightning flashes inside, an ash cloud, volcanic lightning, formed when ash particles collide and charge the air. It's nature's paradox, fire creating electricity within smoke. You watch it illuminate the night, each flash revealing the immense shape of the plume, expanding, curling, dissipating. It's easy to fear volcanoes, to see them as destroyers. But without them, there would be no fertile soil, no continents, no air thick enough to breathe. Every violent exhalation is part of a greater balance, a necessary release to sustain the planet's long life. As you watch the last of the lava cool, a faint breeze brushes against your face, warm, mineral-rich, carrying the scent of creation. The eruption has ended, but the story continues below. Magma chambers refill. Pressure builds again. The earth breathes in and out. Maybe you realize, in that moment, that even the fiercest things can be acts of love, that renewal sometimes wears the mask of destruction. The volcano sleeps once more. The stars return above it. But deep beneath, the molten heart continues its slow inhale, preparing, always, for the next exhale. Earthquakes. The sudden pulse. They arrive without warning, a jolt, a tremor, a breath the planet has been holding too long. Then, in a single moment, the the stored tension releases, and the ground beneath you ripples like water under a great unseen wind. Schultz, 2002. You stand upon a fault line now, one of Earth's many seams. The land looks still, but deep below, two tectonic plates are locked in a slow struggle. They press, twist, grind, their edges caught like teeth in a vice. For decades, maybe centuries, they resist each other's motion, building pressure, grain by grain, atom by atom. Then, the release. At first, you feel nothing. Then a low groan, deep and distant, rolls through the ground. It grows, swells, and in an instant, the solid earth ripples. The trees sway in unison. Waves ripple across roads like liquid. Mountains tremble, valleys shiver. It's not noise you hear, but motion, a frequency that hums through every structure, every heartbeat. The energy travels as waves first, the swift P waves, compressing and expanding the rock like sound. Then the slower, rolling S waves, shaking the ground side to side. These waves radiate outward from the fault, like concentric rings, each carrying a piece of the planet's released breath. Lay and Wallace, 1995. From high above, you can see it, the shock rippling through crust and mantle, spreading through continents and oceans alike. It's as if the Earth has flinched in its sleep. Some earthquakes are small, barely whispers, recorded only by seismographs. Others reshape history. 1960, Chile, magnitude 9.5, where the entire coastline rose and fell. 2011, Japan, where the seabed shifted meters in seconds, unleashing tsunamis that crossed oceans. Every quake tells the same story. Tension built by the slow dance of plates, released in a single sudden gesture. You drift deeper into the crust now, along a fault zone glowing faintly from frictional heat. Tiny grains of quartz sparkle, crushed and ground into glass by the motion. Fluids flash to vapor, filling the cracks with pressure. The fault doesn't move smoothly. It lurches, stops, and goes again, a stick-slip motion like a bow drawn too tight, finally snapping forward. In that release, energy becomes motion, sound, heat. The ground fractures, rocks slide, and landscapes rearrange themselves. It is terrifying and necessary part of the planet's way of staying in balance. Scientists study these motions not just to predict them, though prediction remains elusive, but to understand how energy moves through matter. Earthquakes are windows into the deep structure of the crust. Each tremor sends signals that reflect and refract through layers, revealing the composition of the unseen interior. Schultz, 2002. The Earth speaks through these pulses, and we learn to listen. You rise back to the surface and find the landscape changed. A new ridge runs where there was once a plain. The river has shifted course. Cracks split the earth like veins of sudden creation. Yet even amid the damage, new patterns emerge. Faults that will shape future mountains. Valleys that will one day cradle lakes. The quake's aftershocks roll gently now, smaller echoes of the first. They remind you that even the planet takes time to settle after its own heartbeat. Slowly, the vibrations fade into silence. You kneel and touch the ground. It feels solid again, yet different, rearranged, renewed. Beneath it, stress begins to build once more. The plates never stop moving. They only pause between breaths. You think of how similar this is to your own body tension held too long, then released in sudden clarity. The Earth, like you, needs to let go sometimes. Without that release, pressure would build until the crust shattered completely. Even destruction can be an act of healing. You listen closely and realize that earthquakes are not random outbursts, but punctuation in a longer story. The same friction that shakes cities also uplifts mountains and exposes minerals that feed life. The same movement that topples buildings also deepens the planet's rhythm. In this balance of creation and collapse, you find a strange peace. The world doesn't seek perfection. It seeks motion. As the dawn light touches the fault line, the Earth rests once more, still but not silent. Deep below, new strains begin to build. Somewhere, another fault locks into place. Another pulse prepares to form. Maybe that's what keeps the planet alive, not stillness, but the constant renewal that comes from release. You take one more look at the ground, so calm now, and feel gratitude for its hidden motion, even when it shakes. It's only reminding you of the life that flows beneath your feet, the heartbeat that never stops, even when the world seems still. The magnetic shield, Earth's invisible armor, the unseen cocoon that wraps the planet in safety and song. It's not made of stone or air, but of motion. Molten metal swirling deep within, giving birth to a field that touches every compass, every aurora, every life on this world. Olson and Christensen, 2006. You begin your descent toward the core once more, passing through the mantle's soft glow until all that remains is the deep, metallic shimmer of the outer core. Here, iron and nickel are not solid but fluid, a vast ocean of liquid fire, circling thousands of kilometers below. You can feel it moving, swirling like molten honey, carrying heat outward and pulling energy into graceful spirals. The outer core churns because of convection, just like the mantle hot material rising, cooler fluid sinking. But here, the stakes are higher. The motion of this conductive metal, coupled with Earth's rotation, generates electric currents, and those currents, in turn, create a magnetic field that extends far into space. The geomagnetic field, the invisible shield that makes our world habitable. Olson and Christensen, 2006. You hover at the boundary between the inner and outer core. The sound is a low hum, a frequency that vibrates through you, like the deep note of a planet-sized tuning fork. This is the geodynamo in motion, liquid iron spiraling in endless patterns, generating magnetic lines that stretch outward through the mantle, the crust, and far beyond the atmosphere. Up at the surface, you can't see this field, but you feel it every time a compass needle swings north. You see its beauty when charged particles from the sun collide with it, creating curtains of light auroras rippling across the poles. Green and violet waves shimmer in the upper sky, dancing in silence. The lights you see there are the outer echoes of the planet's molten heart. You rise with those magnetic lines now, following their graceful arcs through the crust and into the sky. They curve outward, forming a protective bubble, the magnetosphere that deflects solar wind and cosmic radiation. Without it, the atmosphere would slowly be stripped away, as it was from Mars long ago. Without it, the planet would bake in ultraviolet fire. The shield is not decoration, it's survival. High above, the solar wind pushes against this field like waves against a ship's hull. The pressure bends it, shapes it, but never breaks it. On the day side of the Earth, the field compresses. On the night side, it stretches into a long tail that trails into the void. From afar, it looks almost alive, pulsing, shimmering, reacting to every solar storm. You float inside that invisible cocoon, feeling the magnetic field brush gently across your skin. It's faint but constant, a silent current that guides birds in migration, whales in deep-sea journeys, and even bacteria that align themselves to its pull. Many living creatures can sense it, a phenomenon called magnetoreception. To them, it's not invisible. It's a compass written into their cells. Wilczko and Wilczko, 2005. The realization strikes you softly. The same field that protects you also guides life, shaping instinct and movement. The planet's heart doesn't just beat, it whispers directions to every living thing that listens. But even this shield is not permanent. Every few 100,000 years, the magnetic field flips. North becomes south, and south becomes north. The process, known as geomagnetic reversal, takes thousands of years. But it never destroys the field, only reorders it. Lava flows on the ocean floor have recorded these flips, their iron minerals frozen in the direction of ancient fields. They are, in a sense, the memory of Earth's changing heartbeat. You think about how the planet's protection comes not from stillness, but from motion. The outer core must keep moving, swirling, evolving for the field to live. If it stopped, the shield would fade, the magnetosphere would collapse, and solar winds would strip away the atmosphere. Life, as we know it, would unravel. Down below, you sense the inner core spinning slightly faster than the rest of the planet, a phenomenon scientists call superrotation. This differential motion may help sustain the field, keeping the dynamo alive. It's as if the Earth's heart turns within itself, its rhythm slightly out of sync, yet perfectly functional, like a jazz beat that never loses the melody. Song and Richards, 1996. You float upward once more, passing through layers of mantle and crust. The magnetic field extends above you, vast and silent, stretching tens of thousands of kilometers into space. Somewhere out there, solar storms strike it, bending and shaping it like wind through tall grass. The Earth shudders faintly, but the shield holds. Maybe protection is not about being hard or unmoving. Maybe it's about staying in motion, about adapting, shifting, and flowing with the currents that would otherwise destroy you. As the aurora flickers above the poles, you can almost hear it, the quiet crackle of charged particles dancing along magnetic lines, the distant echo of molten iron churning deep below. The Earth's magnetic field is not a wall. It's a song one that resonates from the planet's heart to the edge of space. It reminds you that even in darkness, motion can create light, continents that wander drifting, colliding, reshaping the face of the world over billions of years. They move so slowly that no eye can see it, and yet their journey rewrote the planet's story again and again. Wegener, 1912. You rise now above the Earth, high enough that the curve of the planet becomes visible. From this distance, the continents look fixed, vast, ancient shapes surrounded by blue. But if you could press a button to speed up time, you'd see them drift like ice on a molten sea. Africa sliding northward, India racing toward Asia, the Atlantic slowly widening, the whole surface rearranging itself in a grand, slow-motion dance. It wasn't always known that they moved. For centuries, scientists thought continents were immovable, the solid framework of the planet. But in 1912, a German meteorologist named Alfred Wegener looked at a map and noticed something uncanny. The coastlines of South America and Africa fit together like puzzle pieces. He proposed that they were once joined as part of a single supercontinent, Pangaea. Wegener's idea was radical. He called it continental drift. He gathered fossils, rocks, and glacial evidence that matched across oceans, identical fern species in Brazil and South Africa, ancient mountains continuing from one continent to another. The world, he said, must once have been united, then torn apart. Many mocked him at first, but time and the seafloor proved him right. You descend again, floating above the ancient Pangaean world, 300 million years ago. Beneath a sky heavy with storms, one colossal landmass dominates the horizon, surrounded by a global ocean called Panthalassa. Forests of ferns and towering lycophytes stretch across humid plains. Early reptiles roam among them. You can feel the planet holding its breath, storing energy for the inevitable rift. Beneath the crust, mantle convection builds pressure. Magma wells upward, splitting the supercontinent apart. The first rifts widen, filled with molten rock that will one day cool into the foundations of the Atlantic. You hear the deep, slow crack of stone giving way, the sound of continents beginning to wander. Millions of years pass in moments. Pangaea splits into two great fragments. Laurasia to the north, Gondwana to the south. The pieces drift further, carried by the same currents that move the plates today. Oceans form, close, and reopen. Chains of mountains rise and erode. Continents merge again, first as Rodinia, then as Pannotia, then as Pangaea once more. The Earth doesn't just change, it cycles through creation, a heartbeat of assembly and division. Nansit Ali, 2014. You watch as India, once part of Gondwana, begins its solitary journey northward, a 100 million year migration across the Tethys Ocean. It moves faster than most plates, up to 15 centimeters per year, as if drawn by destiny. When it finally collides with Asia, the impact lifts the seafloor skyward, folding and thrusting it into peaks that will become the Himalayas. Even now, they're still rising. An inch every year, the planet's pulse visible in stone. The world you know is the product of these migrations. The Alps, the Rockies, the Andes, all born from collisions. The rift valleys of East Africa, the Red Sea, the Atlantic itself born from separations. Every border, every coastline, every mountain range is a map of movement frozen in time. You drift closer to the surface now, over the drifting Atlantic ridge, and feel the pull of the continents as they slide apart. The ocean between them grows by about 2 centimeters each year, the width of a fingernail. It doesn't sound like much, yet given enough time, it reshapes worlds. You think of Wegener, dismissed, doubted, yet certain. He never lived to see plate tectonics confirmed, but his insight was the seed of a revolution. Science, like the Earth itself, often moves in slow, unstoppable drifts. As you hover above the shifting plates, you begin to see a pattern. The continents aren't aimless wanderers. Their paths follow the deep currents of the mantle, guided by the same thermal energy that drives earthquakes and volcanoes. Each collision and separation is part of a cycle, the supercontinent cycle that repeats roughly every 500 million years. Murphy and Nance, 2008. Pangaea was not the first, nor will it be the last. In another 250 million years, the continents will drift back together, forming a new supercontinent scientists call Amasia. Perhaps new mountains will rise, new oceans will close, and the face of the Earth will once again change beyond recognition. The planet keeps breathing, expanding and contracting, never still. You rise higher still, until the continents blur into swirling blue and green shapes beneath clouds. Their movements are invisible at this scale, but you know they're happening slow, persistent, inevitable. Maybe that's how the Earth teaches patience, through motion too gradual to see but too powerful to stop. The continents may seem apart now, divided by vast oceans, but deep beneath, they are connected not just by rock, but by rhythm. Each drift, each collision, is another note in the endless song of a planet alive. You feel the motion even now. Faint beneath your feet, the slow wander of continents, the memory of Pangaea in every coastline curve. And you realize, we live on a world that never stops traveling. Cycles of creation and destruction, the Earth's most profound rhythm, written in stone. Every mountain, every grain of sand, every pebble on a quiet shore is part of a vast loop that has never ceased since the planet's beginning. Wilson, 1966. You stand now on the edge of a cliff. Below you, waves crash against black rock, spraying salt and foam into the air. The stone beneath your feet feels solid, eternal. But it isn't. It is temporary part of a cycle so immense it turns permanence into illusion. The rock you touch was once molten magma, born deep within the mantle, cooled in the darkness of the ocean floor. Over millions of years, it was lifted, fractured, eroded, and carried by rivers to the sea again. There, it settled as sediment, compacted into new stone, and one day will be dragged back beneath the crust to melt once more. Creation and destruction, not opposites, but phases of the same eternal breath. You close your eyes and imagine following a single particle of rock through that journey. It begins deep below, in the fiery mantle, rising as magma through cracks in the crust. The magma cools and crystallizes, forming igneous rock, the first solid form. Over time, wind and rain sculpt it, breaking it into fragments. These fragments are carried by rivers, deposited in layers, and compressed into sedimentary rock, a kind of stone that remembers the surface world. Shells, dust, the remains of living things. Then, buried deep under pressure, it changes again. The minerals realign, new ones form, and it becomes metamorphic, a stone transformed by heat but not melted entirely. If buried deeper still, it melts, completing the cycle. This is the rock cycle, the grand recycling engine of the planet. Wilson, 1966. Nothing here is wasted, everything returns. You drift now into the crust, watching this transformation unfold. The boundaries between types of rock blur, their edges glowing faintly where heat and pressure work their slow magic. Time stretches out. What takes seconds in your world takes millions of years here. Layers of sediment stack like pages in a book. Faults shift like edits in a draft. Magma intrudes like ink seeping through parchment. The Earth is rewriting itself continuously. Above ground, the atmosphere plays its part too. Rain, ice, and wind break down stone grain by grain. Rivers carry those grains to the sea, feeding deltas that bloom like branches at the edge of continents. Even the calmest breeze participates, lifting desert dust that will one day fall as silt on the ocean floor. You drift over the Himalayas, watching glaciers carve valleys into the peaks. Each movement grinds rock into powder, feeding rivers that flow toward the plains. The same mountains that rise from collision are slowly worn down by weather. The balance is exquisite. Uplift and erosion, rise and return. The planet grows and humbles itself in equal measure. At subduction zones, where old crust sinks into the mantle, rocks melt again, their minerals separating, their stories erased and rewritten. Volcanic eruptions bring them back upward in new form, newborn rock with the same atoms, rearranged into new patterns. It's a cosmic recycling system, powered by heat, pressure, and time. Somewhere along a coastal ridge, you find a thin layer of clay, all that remains of a great meteor impact 66 million years ago. It's rich in iridium, a metal rare on Earth, but common in asteroids. This thin line marks the end of the dinosaurs, a moment of destruction so complete that it reset ecosystems worldwide. Yet, within a million years, new species flourished. Life, too, follows the rock's rhythm: collapse, renewal, and rise. As you float higher, you can see the pattern from above. Continents eroding, sediments collecting, volcanoes rebuilding. The crust is not a static surface, but a skin that breathes. The cycle of rocks mirrors the cycle of life, both built on death, both finding beauty in impermanence. You remember the law of conservation. Matter cannot be created or destroyed, only changed. Here, the earth lives by that truth. The atoms in your bones were once part of mountains. The calcium in your teeth was once in coral reefs. The iron in your blood once flowed through magma in the mantle. You are part of the cycle, not apart from it. Maybe that's what makes this realization so humbling. The world doesn't discard anything. Even loss is transformation. Even ruin is renewal. You touch the cliff again, feeling its warmth. The rock is silent, but within it, tiny vibrations persist, the hum of atoms rearranging, of time itself at work. You think of everything that has lived and died upon it, everything that will one day wear it down. It feels eternal, but you know better now. Eternity here is movement, not stillness. The waves crash below, relentless, ancient, soft. Each one carries away a fragment of the cliff, one grain closer to the sea. Destruction or continuation? You can't tell anymore. Perhaps they are the same thing, wearing different faces. As you turn to leave, a gust of wind rises from the ocean. It carries the scent of salt and stone, and something older still. It smells like memory. The earth continues to breathe, its cycle unbroken. Rocks melt, cool, crumble, and rise again. And through it all, the heartbeat endures quiet, patient, infinite. The planet's inner rhythm, a heartbeat we cannot hear, yet one that moves through every mountain, every tremor, every whisper of wind across the land. It is the deep music of seismic waves, the sound of the world's core echoing upward, proof that beneath the stillness, the earth is very much alive. Dziewonski and Woodhouse, 1987. You begin this journey in silence. The air is still, the surface calm. Then, faintly, you sense it. A vibration, gentle and continuous, rippling through the ground. It's not an earthquake, not a violent burst of energy, but something subtler, more persistent. A low hum, rising from within. The earth itself, resonating. This rhythm comes from seismic waves, the planet's internal language. When a quake occurs, the energy it releases doesn't vanish. It travels through rock, bending, reflecting, refracting. Some of it circles the entire planet. Again and again, long after the surface has gone still. These waves, recorded by sensitive instruments, tell the story of Earth's interior, revealing its layers, its structure, and its pulse. Dziewonski and Woodhouse, 1987. You drift downward into the crust, following the faint tremors like music in a dark hallway. The waves here travel quickly through dense granite, slowing as they meet pockets of softer sediment. Some are compressional P waves, pushing and pulling the rock as they move. Others are shear waves, S waves shaking side to side. Together, they form an invisible symphony beneath every step you take. Far deeper, through the mantle, the waves curve as they meet changes in density. You can almost see them rippling through molten minerals, their paths bending like light through glass. They speed up, slow down, bounce from boundaries, whispering secrets about what lies below. Scientists like Dziewonski and Woodhouse once used these faint signals to map the entire Earth's interior from crust to core, like doctors listening to a heartbeat through a stethoscope. At about 2,900 kilometers deep, the waves meet the core mantle boundary. Here, something extraordinary happens. Shear waves vanish, unable to pass through liquid, but compressional waves continue, bending around the molten outer core. That disappearance is how we first knew the outer core was fluid. The Earth told us itself, through vibration. As you float at that boundary, you can hear it, the low, resonant thrum of the outer core swirling, generating the magnetic field you visited before. Each motion, each eddy, sends out vibrations that ripple upward. It's like hearing the murmur of a great engine through layers of stone. The sound is so deep it's almost felt more than heard, a pulse measured not in seconds but in centuries. Deeper still, the waves strike the inner core, solid iron, crystalline, resonant. Here, the vibrations grow purer, clearer, almost musical. Scientists have found that the inner core may not be uniform. It has layers of its own, and may even oscillate slightly, rotating faster or slower than the rest of the Earth. Song and Richards, 1996. The result is a slow, rhythmic wobble, a beat within the beat. You realize now that every quake, every eruption, every mountain uplift is part of this deeper rhythm. The Earth doesn't move randomly. It pulses in patterns, energy building, releasing, traveling, returning. Even the microseisms, tiny tremors caused by ocean waves colliding, contribute to the hum. The planet sings continuously, even when no one is listening. Nishida, et al. 2000. You rise upward again, through the mantle and into the crust. The hum softens, becomes more subtle, yet it's still there, a faint, trembling, steady as breath. The same waves that seismographs detect in labs are vibrating through your feet right now, through the bedrock beneath your home, through the oceans, the mountains, the cities. Above, the wind stirs, clouds drift, and rain falls, all powered by the heat that drives the same deep rhythm below. The planet's outer systems, like its inner ones, follow the same cycles of motion and rest, tension and release. The rhythm connects them all, from molten core to clouded sky. You think about your own heartbeat, how it rises and falls, responding to emotion, exertion, life itself. The Earth has its own, hidden beneath kilometers of rock. It beats slower, yes, but it beats just the same. And perhaps, in ways we can't measure yet, our lives are synchronized to it, our tides, our sleep, our very sense of time echoing its ancient pulse. You listen closer, and the sound becomes almost meditative, a deep, slow oscillation that feels familiar. Maybe this is why we find comfort in the sound of waves or wind through trees. Those are just smaller echoes of the same vibration, the world's way of breathing. You float upward into the quiet night, looking down at the planet glowing faintly in starlight. From this distance it seems peaceful, asleep, but you know better now. Beneath that calm surface, motion never ceases. Energy rises and falls in endless cycles. The Earth hums to itself, and you, somehow, hum with it. Maybe that's the secret connection we've always felt, the sense that being alive means moving, pulsing, vibrating with something greater than ourselves. And if you could listen long enough past the sound of cities, past the whisper of oceans, maybe you'd hear it clearly. The deep, slow heartbeat of a world that never stops singing. The fragile surface above a thin, trembling skin stretched over a furnace. It's easy to forget how delicate it really is. How this narrow zone between fire and sky is the only place life can endure. Sleep, 2000. You hover now just above the crust, the line that separates the living world from the molten one. The surface looks solid: mountains, plains, oceans, but in truth, it is the thinnest shell of all. If Earth were the size of an apple, the crust would be no thicker than its skin. And like skin, it's scarred, stretched, and constantly renewed. Below you, convection currents in the mantle churn endlessly, pressing upward against the crust. Above you, the atmosphere presses down with oceans of air. Between these forces lies the fragile balance that makes life possible. It's a balance measured in millimeters and degrees, the thickness of soil, the tilt of an axis, the chemistry of a single gas. You drift down toward a forest. The trees sway gently, their roots reaching into rock that was once magma, their leaves breathing air exhaled from ancient volcanoes. Life has taken this fragile crust and woven it into a garden. Yet all of it, every tree, every blade of grass, Every cell depends on the stability of a layer thinner than the distance from your fingernail to its edge. When the crust shifts, as it often does, the surface transforms. Earthquakes tear cities apart. Volcanoes blanket skies in ash. Tsunamis redraw coastlines. It is the planet's reminder that we live on borrowed calm. Underneath, heat builds and rock flows. Above, wind erodes and rain dissolves. The middle layer, this crust, is the brief pause where life resides. You descend further, into the soil itself. A few meters down, temperature stabilizes. A few kilometers, and it begins to rise again. 10 degrees for every kilometer deeper. That gradient, the geothermal gradient, is the warmth that seeds both danger and comfort. It powers volcanoes and hydrothermal vents, but also keeps the planet's interior alive. In this shallow zone, only the upper few kilometers, all of human history has taken place. Civilizations rise and fall on the surface of an eggshell, unaware of the roaring engine beneath. We build monuments, dig tunnels, plant fields, all on shifting ground that breathes like muscle over bone. You drift through layers of rock, sediment, basalt, granite. Tiny fissures glimmer with quartz, carrying water that seeps from the surface. These fractures are lifelines. Through them, minerals circulate, forming veins of metal and crystal. Without such cracks, there would be no gold, no copper, no springs bubbling clear from mountain stone. Fragility creates beauty. Above, you see the delicate balance extend into the sky. The crust gives rise to volcanoes, which release gases that maintain the atmosphere. That thin air, less than 1% of Earth's total radius, protects us from cold space and blazing sun. Remove a few molecules of greenhouse gas, and the planet freezes. Add too many, and it burns. The same fragility applies upward as downward. From orbit, the atmosphere glows like a faint blue halo. From space, it looks peaceful, timeless. But you know that every breath, every leaf, every wave depends on it, on a layer so thin that if Earth were a basketball, the breathable air would be a coat of varnish. Life, it turns out, is sustained by a film. You think of how many times the crust has cracked and reformed, yet still supported life. When asteroids struck, when supervolcanoes erupted, when continents tore apart, still the surface healed. Its fragility is matched only by its resilience. Somewhere beneath your feet, microbes live kilometers deep, feeding on chemical energy from the rock. They are called extremophiles, and they remind you that even here, in darkness and heat, life endures. The boundary between death and survival is thinner than we imagine. You rise again, passing forests, rivers, mountains. The crust stretches endlessly below, yet remains fragile, a floating raft on liquid stone. You realize how easily it could all vanish, how brief this calm epoch truly is. But you also realize how miraculous it is that it exists at all, that the right balance of heat, chemistry, and time created a world capable of sustaining such fragile beauty. Maybe that's what makes life so precious. It thrives not despite the planet's instability, but because of it. Volcanic ash enriches the soil. Tectonic uplift exposes minerals. Weathering creates nutrients. Every risk is also a gift. The surface trembles slightly beneath your feet, the faint pulse of the mantle below. It feels alive, like a heartbeat through stone. You close your eyes and listen. For a moment, you can sense the entire planet breathing beneath you, heat rising, air falling, crust shifting. The fragility doesn't frighten you. It comforts you, because in that fragility lies a truth. Stability is not the absence of motion, but the balance within it. You open your eyes. The wind rustles the leaves. A volcano smokes faintly on the horizon. Somewhere, deep below, magma flows in silent loops. You stand between worlds on the fragile surface above a living heart, and for the first time, you feel both small and infinite. The pulse that never stops. The molten rhythm that began when the planet was born, and will continue long after we are gone. Turcotte and Schubert, 2014. You close your eyes, and for a moment, you listen not to the wind, not to the ocean, but to something deeper. A vibration, so low it's almost beyond hearing. The slow, steady throb of the Earth's core, pushing heat outward, pulling mountains upward, breathing continents apart. The planet's heart still beats, slow and certain, somewhere far beneath your feet. You drift now through layers you've seen before. The cool crust, the glowing mantle, the churning outer core. But this time you move not as an observer, but as a listener. Every layer hums its own tone, iron swirling, rock shifting, magma whispering through cracks. It is not random noise, but rhythm, a constant, unbroken pulse that keeps the world alive. Deep in the outer core, liquid iron flows in endless circles, sustaining the magnetic field. Heat moves upward, powering the mantle's slow convection. The mantle's motion drives the plates, lifting mountains, tearing oceans open, sending tremors through the crust. Every earthquake, every volcano, every drifting continent, all are surface echoes of this ancient heartbeat. And above, life breathes in time with it. Trees draw carbon from the air that volcanoes once exhaled. Rivers cut valleys where mountains have risen. Creatures live, die, and turn to stone, only to rise again as part of the next continent. Even the sky, the thin blue veil that shelters you, is sustained by gases recycled through the crust and mantle. Nothing here stands still. Nothing here is wasted. You drift farther inward, into the silent brilliance of the core. The pressure here is unimaginable, millions of atmospheres. The temperature, hotter than the surface of the Sunday. And yet, within that storm of metal, order persists. The inner core, solid and crystalline, rotates ever so slightly faster than the rest of the Earth. Some scientists think it wobbles like a pendulum, a steady rhythm that may subtly alter the planet's magnetic field. Buffett, 1996. If you could translate that movement into sound, it might resemble a slow, steady drum, the world's original metronome. The Earth does not grow tired. For 4.5 billion years, its molten heart has churned, its crust has moved, its surface has changed, and still, it continues. Even as mountains crumble, as continents drift, as species rise and vanish, the inner rhythm remains the same. Creation, destruction, renewal, an endless cycle pulsing through time. You imagine what the planet might look like eons from now. The continents merged again into a new supercontinent. Oceans redrawn. Volcanoes lighting the skies over new lands. The magnetic field flipping once more. The heartbeat will continue, altered in tone but not in tempo. The song of the earth will outlast us all. And then you look closer at yourself. Your pulse, steady and quiet, beats in time with this world. The iron in your blood was forged in the same cosmic furnaces that birthed the planet's core. The calcium in your bones was once part of the ocean floor. The water in your cells is as old as the first rains that cooled the crust. You are not separate from this heartbeat, you are one of its rhythms, one note in its endless music. The thought brings you calm, because even when you are still, the earth is not. Even when you sleep, the magma flows, the tides turn, the crust shifts. The planet breathes beneath you, patient and strong. Its heart beats in the dark, and through it, so does yours. Perhaps that is the truest comfort of all, that the world continues. That long after our words, our stories, our cities fade, the rhythm will remain. The pulse that began in fire will keep echoing in silence. The universe hums with billions of such hearts, stars, moons, planets, all beating in their own time. But tonight, you listen only to this one. The soft, deep heartbeat of the earth. You let it lull you. The ground beneath you feels warm, alive, breathing. The rhythm slows, the pulse steadies, and as your eyes grow heavy, you realize you are resting not on solid ground, but on a living heart. Sleep well. The earth is still here. Its heartbeat is strong, and it will keep singing softly, endlessly while you dream. The rhythm slows now. The story fades into the hush of night. You feel the weight of gravity, the pull of warmth beneath you, the pulse of the planet steady and sure. It's easy to forget, in the noise of living, that the world beneath your feet is alive in its own way. That beneath cities and oceans, under mountains and plains, molten rivers still flow. The same fires that forged this planet still burn quietly in the dark. But tonight, as you drift towards sleep, you know that you are safe in that rhythm. The crust may tremble, the seas may shift, but the heartbeat continues constant, patient, timeless. You think of all the places where the planet breathes. The volcanoes sigh, the oceans tide, the rustle of leaves stirred by unseen air, each one a note in the same quiet song, a lullaby that has lasted for billions of years. Maybe that's the secret the Earth has been whispering all along. That balance isn't stillness. It's motion in harmony. Creation and destruction, peace and power, each part of the same dance. So, you breathe with the planet now slow, even steady. Feel its pulse beneath you, ancient and unbroken. The same rhythm that guided the first spark of life still hums through your bones. The universe is still here, quietly working while you sleep. The mantle still moves, the stars still burn, the earth still breathes, and in the silence that follows, all is well. The gravitational waves from colliding stars ripple invisibly across space, stirring the same sea of particles from which you came. You are part of that vibration, woven into its rhythm. Maybe that's why looking at the night sky feels like recognition. When you stare upward, you are not gazing into the unknown, you are looking homeward, across time. The light from distant stars touches your eyes and becomes vision. Their energy becomes emotion. Their pattern becomes meaning. The solar system, once only dust and gravity, now looks back upon itself and wonders. The experiment succeeded. Out of raw matter came perception. Out of chaos, curiosity. Out of the impersonal, love. You drift farther out, past Neptune, past the Kuiper Belt, past the frozen edge, where the sun becomes a distant spark. The planets shrink to points of light, indistinguishable from the stars beyond. You realize that from this distance, the entire history of the solar system collapse, fire, rain, thought fits into a single dot. And yet, within that dot is everything. Every dream, every sunrise, every heartbeat. The universe, it seems, wanted to know itself, and so it made you. You close your eyes and breathe slowly, deeply, as the cosmic hum fades into the background. Somewhere inside you, the atoms of ancient stars remember their long journey, from dust to planet, from planet to life, from life to awareness. And though your story feels small, it is vast beyond measure, because you are the dust that learned to ask why. Now, as you rest, imagine the solar system turning in its endless night, the sun's soft fire glowing across the cold expanse, each planet moving through its rhythm like a heartbeat slowed to infinity. Everything that had to happen for you to exist, every explosion, every collapse, every comet's fall has already done its work. The universe is still here, quietly working while you sleep. You are surrounded by it, even now. The same gravity that holds the planets in orbit keeps your feet on the ground. The same light that shaped the earth now warms your skin. The chemistry that began in ancient clouds still flows through your veins. You are not separate from the stars, you are the way they continue. Let your thoughts slow to the pace of the planets. Mercury whispers close to the Sunday, Jupiter breathes deep in the cold. Saturn's rings drift like frozen music. Far beyond, Neptune hums softly in the dark. All of it continues, steady and serene. Breathe in. The air is ancient, billions of years old, made and remade by countless forms of life. Breathe out. You give a little of yourself back to the same cycle. Nothing is lost. Everything transforms. The solar system is not a story of chaos, but of persistence, a patient unfolding toward beauty. Even when everything seemed violent, it was only creation in disguise. The dust that once burned in the heart of stars now dreams in you. So, close your eyes. The universe is vast, but it is gentle tonight. Somewhere above, the stars keep their quiet watch, and the sun, your oldest ancestor, still burns for you. Sleep well, child of stardust. You are home.